We're looking at problems in Calculus 1, and of course this falls under integration. We're going to be looking at the mean value theorem and the average value of a function. And of course this is for integrals. First theorem we're going to look at here is the mean value theorem, also known as the MVT, for integrals. And let me just state it here. Of course we need to have a continuous function on a closed interval between a and b, and there exists a number c in the closed interval ab such that this is true. And so let's go jump and look at an example. Let's look at 0 and 1 of 3 of just a constant. So we're going to look at something really simple here. Now I guess I need to state that once again. That was a, I should have done this first, b of some function f of x dx, and it's equal to f of c, and the interval is b minus a. And the idea here is we want to find c. We want to find c. And so the first thing I'm going to do is evaluate this, and this becomes 3x, and we're going from 0 to 1, and of course this just becomes 3 times 1, which is 3. So now that we have found this here, we're going to put 3 here, f of c, and if our function, I should write out here, is f of x is equal to 3, then f of c is equal to 3, because, well, there is no x over here to plug c into, so f of c has to be equal to 3. So f of c is equal to 3, and then b minus a, we're going from 0 to 1, so this is 1 minus 0. Well, this is actually kind of funny because 3 is equal to 3. So the question is, what is c? Well, c could be anything. Let's draw a graph here, and let's make our function the graph of the function a different color. And of course this is 3 here. We're going between 0 and 1 is what we're looking at. So we're talking about the average, well, we're talking about the mean value theorem here. You can pick any number in here, and basically it's the mean. I shouldn't say that, but so any number on between 0 and 1, okay, satisfies that theorem, the f of c. So there's an infinite number of f of c's. Well, they're all the same value. Maybe we should look at something different. Let's look at this one here. Let's go between 0 and 2 this time of x dx. So our function f of x is equal to x, and of course we'll scribble out a graph here so we get something to look at. And we're going between 0 this time and 2. The mean value, I guess the mean is somewhere about here. It's just a guess. So we're looking for we're trying to find the c. First thing I'm going to do is, I guess once again, maybe I should do this. Write that out. It's equal to f of c and b minus a. This becomes x squared over 2 from 0 to 2. So this is 2 squared over 2, which becomes 2. Okay, and so 2 is equal to, now we're going to plug c into our function, and that just becomes c times b minus a, which is 2 minus 0, and c equals I want to scroll up here, something I said earlier. There was an infinite number of f of c's. There's an infinite number of c's, I should say, that, anyway, infinite number of c's that you can plug in. We was looking for one unique c, but there's a whole bunch of them in here. Alright, let's just go back. Saves me time and have to do cut, paste, edit, and all that. We were in this particular problem here, we were trying to locate c, and there's one unique c in this interval between 0 and 2, and that is c is equal to 1. So I pretty much had that correct. C is equal to 1 right here. Alright. If I said f of 1, what is f of 1? Well, we plug it in and we get 1 out. This is known as the average value. This is known as the average value right here. The average value, which is 1. And that's where we're actually heading next, and that is looking at the average value. So in the beginning of this video, we were looking at the mean value theorem, but remember up here in the top, we mentioned something about the average value of a function. Well, now there's a relationship with the average value of a function on this interval and the mean value theorem. In the theorem here, we're trying to find the actual c. In this part, this is the average value of a function. Of course, I guess we should go ahead and state it. If f is integrable on the closed interval a, b, then the average value of f on the interval is. So in this particular one here, we're trying to find c. And in this, we're going to actually try to find, well, think about this. If you took the b minus a and you brought it, you divided both sides by b minus a, or you multiplied by 1 over b minus a to both sides, what we're going to actually get here is f of c is going to be equal to all of this. And we said that that was the average value. So we're going to be looking at this now. And in most, even a business calculus class, this is pretty important and you'll be tested on this. This here may not be mentioned in a business calculus class, the mean value theorem, or I'd say a watered down calculus class, what I should say. But for engineers, both of these will be mentioned. Let's scroll down and look at a different one. And of course, we're looking at the average value now. And we're going to go ahead and state that 1 over b minus a of the integral between a and b, f of x dx. So you're going to be asked to find the average value. And let's say that we are going to be 0 to 2 this time of, I don't know, let's do x squared dx. How's that? We're going to take we're going to integrate this thing. Okay, x cubed over 3 going from 0 to 2. And we have 2 cubed over 3 is basically going to be our answer, which is 8/3. Now, of course, let's not forget this piece here, which I actually did. This is 1 over 2 minus 0, which is a half, so we don't need to forget that. And times that by a half, and we're going to end up getting, this simplifies down. Let's see, that's going to be 4/3. 4/3. And if we looked at the graph here, I should have stated that f of x is equal to x squared. We're on the interval between 0 and 2, and we want to find that average value. So we're going to sketch out a graph here. Let's say that this is 2. Now remember, the mean value, we were looking for a c here. We wanted to find that c, and then of course f of c was actually going to be equal to, So we said f of c would be equal to 4/3. That's the average value. And then of course, what is this c right here? Right, what in the world is that going to be? Well, we started out with x squared. If we were asked to find c, right, so this goes back to the mean value theorem, that there exists a c as long as this is continuous on this interval here. And okay, I'm not stating the entire theorem, but as long as you get the idea. So there exists a c such that it equals 4/3. And of course, to find this c, right, to find the c, all we need to do is take c and plug it into the function up here and solve for c in this problem right here, which we'd square root both sides and get that, which is something like approximately 1.15. Right, just an approximation. Well, remember when we did our f of x was equal to x, if we were on the interval between 0 and 1, if we were on the interval between 0 and 2, our c would be 1, remember? But this time it's moved slightly to the right, and that's got something to do with our function curving right here. But anyway, a little something extra to think about. So all you got to do is, if you were asked, and more than likely this is what it will be, you'll be given some function. For example, we'll do something easy, and we're on the interval between 0 and let's say 3, and you're asked to find the average value. You're asked to find the average value, so you're going to use this. This is what you're going to use, and then of course we need to set it up, and that is 3 minus 0, and a is 0, lower bound, upper bound, and of course x plus 1 dx, and you're going to be asked to find the average value, right? The average value. And when we usually say value, we mean, if you were looking at that as an ordered pair, we're basically talking about the y-coordinate. Okay, so this is 1/3 times, and this is going to be x squared over 2 plus x, and we're going from 0 to 3, and we plug our stuff in. I don't think I'm going to actually work all this out, but 1/3. So plugging 3 in, you get 3 squared over 2 plus 3 minus, and if we plug 0 in, 0, you get 0, so all that just becomes 0, right? And I'll let you actually work out the arithmetic. But this is, if you're asked to find the average value, you're going to be given the function and the interval, and it's going to say find the average value. All right. For the mean value theorem, it may say find c using the mean value theorem. Maybe hopefully they'll say that using the mean value theorem find c. Well, we'll know what we need to do then is remember that f of c is going to be equal to all of this stuff, and we'll just say that this stuff is we'll say it's a. All that stuff is, well, I shouldn't say a, huh? Z, I don't know. All of this stuff right here is equal to z, and then you're plugging c back into the function up here, so this becomes c plus 1 is equal to z. We said all this was equal to z, and then of course solving for that. So on the mean value theorem, you're going to be looking for c. But in the average value, right, you're going to be using this right here to actually find what that value is. I think that wraps up the mean value theorem and how it's related to the average value theorem. And maybe at some point in time, I'll go back and elaborate more on it. But right now, that's it.